AERODEFECTSCAN is a platform for automatic defect detection in solar plants. It is composed by two main platforms, an aerial robotic and an image processing platform. Regarding the workflow, first of all, each flight is planned by using the aerial robotic hardware and software. The second phase is the image acquisition, geolocated thermal and RGB images according to the requirement defined by the image processing platform. Automatically, image datasets are transferred from the aerial robotic platform to the image processing platform. And finally, in the image processing platform, the images are mapped, panels are segmented and defects are detected, displayed the result of the inspection in a visual report directly in the user interface.
Several flights has been carried out during the project in a real photovoltaic plant located in the south of Spain. It is a solar plant with 9.55 megawatts of power and about 50,000 panels. The distribution is based on two panels in vertical, with polycrystalline and monocrystalline modules along the plant. The project has been focused on a small area of the entire plant. The area is very significant due to the huge number of defects to test the capability of the system. The flights has been carried out with a GCD between 3-4 cm per pixel, altitude between 20 and 30 meters, and a camera angle of -45 degrees in order to avoid sun glare. The flight days has been selected to have a solar radiation around 500 watts per square meter, regardless the variable weather condition.
The images acquired by the aerial robotic platform are automatically transferred to the image processing platform. First of all, the images are sent from the UAV to the ground control station. The end of the process is the transfers to the image processing platform using a FTP service. The synchronization between the platforms is based on MQ2T. For instance, when the image transfer process is finished, the aerial robotic platform sends a trigger using MQTT to the image processing platform in order to notify the end of the sending service. Once the image has been received in the image processing platform, its sensor pictures are separated in a specific folder. The second step is when raw data are extracted from radiometric thermal file, and directly the IPP software starts automatically the RGB and thermal mapping generation. Solar panels are detected in the RGB mosaic. Convolutional neural network with UNet architecture has been trained with different types of panels and variable weather conditions. Defect detection are performed in thermal mosaic. ROVIMATICA version 2 has been trained to panel defect classification. The process is fully automated. Image transfer from the UAV to the image processing platform, the thermal raw data extraction, the 4-band mapping generation, the panel detections, and finally the defect classification. The main results are higher than 99% in the panel detections, higher than 97% in the defect detection.